This video covers the two ways to measure variance. So far we've talked about measures of central tendency, right? We've talked about mean, median, mode, one number that represents a bunch of data. Today we're going to talk about two ways to measure variance. Variance is how spread apart the numbers are. So are your data points close together or are they really spread apart? Now, most of you have already heard of the first measure of variance, and that's range, right? Range is the maximum, oh, that's really thick. The maximum minus the minimum, or the largest number minus the smaller number. Maximum minus the minimum. Again, maximum is the largest number in your data set. Minimum is the smallest number in your data set. You probably learned this in elementary school already, but there's actually one new measure of variance we're going to go over today, and that's the interquartile range, right? The interquartile range, commonly known as the IQR. Interquartile range is just like the range, but instead of subtracting the minimum from the maximum, you're going to do third quartile minus the first quartile. And then some textbooks call it differently. Some textbooks, instead of calling it the third quartile, they call it the upper quartile. And then instead of calling it the first quartile, they call it the lower quartile. And we'll go over what quartiles are in a bit. But first I want to talk about why we have variance, right? What is variance useful for? So we have two data sets. Data set 1 is here. Data set 2 is here. I'm going to find the mean, median, and mode of this data set. So let's start with the mean. If I add up all these numbers, I end up with 240. And then since there are 8 numbers, I'm going to divide by 8. This gives me a mean of 30. For the second data set, same thing, right? If I add up all the numbers, I end up with 240 again. Divide by 8, and I get a mean of 30. So these two data sets have the exact same mean. What about the median? Median, let's see, I have to put them in number order, so 15, 18, 21, 22, 28, 30, 50, and 56. Is that 8 numbers? 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then even, oh man, so 2 middle numbers. So my 2 middle numbers are 22 and 28. If I add them together, that's 40, 50 divided by 2. So the median is 25. For this one right here, data set number 2, oh, my smallest number is 26. And then there's 2 28s. And then 29. And then 30, 31, 32, and 36. So again, with 8 numbers, there should be 2 numbers in the middle. And my median is these two, so 29.5. And then for mode, any number appeared twice? No mode. No mode. For mode, for data set 2, I have 28 appears twice, so the mode is 28. So these two data sets, they have the exact same mean. Their medians are close. And one has no mode, one has 28. But there's a big difference, right? Like if you look at the first data set here, I got some numbers in the 50s and some numbers in the 10s. But data set 2, they're all pretty close. They're all in the 20s or 30s. So that's where variance comes in, right? Variance is how spread apart the numbers are. So with this data set 2 here, it should have a really low variance, right? The numbers are really close together, while data set 1 has a really high variance. And the easiest, fastest way to do variance is range. So if we do range, the range of the first one, the largest number or the maximum is 56, minus the smallest number is 15, and that's equal to 41. So a variance of 41 for range. Data set 2, if we measure the range, largest number is 36, smallest number is 26, so the range is only 10. Notice how at the variance there's a drastic difference in variance, right? Because the range, here the range is a lot smaller. That means the numbers are much closer together. Here the range is a lot bigger. That means the numbers are really spread apart. So we have range. So why do we need to learn this new thing, IQR? Right? What's the difference between range and interquartile range? I think the major difference is just why we all have mean and median, right? Remember how mean and median are both pretty good unless there's an outlier. If there's an outlier, the mean is not a good measure of central tendency. Same thing happens to range, right? If I add an outlier, let's say if I add 500, that doesn't affect the median, but it's going to really change the mean. Same thing for range. If I add 500 for the outlier, the range is no longer 41. It's going to be, the range will be now 500 minus 15, so 485, right? So the outlier screws up the mean. If you have an outlier, it messes up the mean, but it also messes up your range, right? Because the outlier by definition is either really big, which will give you a new maximum, or really small, which will give you a new minimum. Either way, the outlier will be bad for the range. So that's where interquartile range comes from. Interquartile range is very similar to the median. So the median gets the exact middle number, right? The interquartile range, it's targeting the middle 50%. And we're going to go over that here. Okay. The interquartile range is often associated with the box plot, or in the olden days we called it box and whisker plot, because here's what a box and whiskers look like. If you have like a cat, and you have some whiskers, all right, two cat eyes. So they used to call it box and whisker plot. Nowadays we just call it a box plot instead of there's just a line here and a line here instead. But they really mean the same thing, right? This line in the middle, that's your median, right? So to find the IQR, you generally draw a box plot. And to do that, we always start with finding the median, right? So we order things from least to greatest because that's what we do when we're finding the median. And then the median. If there is one singular median, that is not part of your first half and your second half, right? You're trying to divide your data into halves, the first half and the second half, with the median not part of it in the middle. Okay, so find the median is your first step. Once you have your median, again, your median splits your data in half. Then the first half is the median of the first half of your data. That's the first quartile. So let's say in this example here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, which gives us the fifth number as the median, which means there are 4 numbers in front of it and 4 numbers behind it, right? So the 4 numbers in the first half, 4 numbers in the second half. Again, the median's not part of either halves. So if we look at just one half of our data and find the median of that half, so this half has 4 numbers, and if I were to find the median of these 4 numbers, it would be the average of the middle 2, right? So I add 17 with 19 to get 39, 38. Wait, 17 plus 9, 36, sorry, 36. And then we divide by 2 to get 18. So you find the median of the first half, and same thing, median of the second half. Out of these 4 numbers, the median would be the average of the middle 2, 26, 28. The median there would be 27. So the first quartile would be the median of the first half, 18. Second quartile is also known as the median. And then the third quartile is the median of the second half. In this case, 27, right? Think about it as if this is 1/2, then this is 1/4, and 1/4 is quart. And this would be 3/4, or the third quartile. Or in this case, lower and upper, right? So first quartile, lower quartile, they're same. Third quartile, upper quartile are the same. And then generally you plot points, right? You have the minimum, first quartile, median, third quartile, and maximum. And then in a box plot, you just draw straight lines. And then connect the first and third quartile as a box with a line through the median, right? So first and third quartile is a box, line as a median. And then lastly, the interquartile range. The interquartile range is the distance between the first and the third quartile. It is the width of the box. So it is the width of this box right here, that range, right? This is first quartiles right here, third quartiles right here. So the range of the quartiles would be the third minus the first. So in this case, 27 minus, what is that, 18? 27 minus 18, which is 9. So this box is 9 units long. So that's our IQR. Our IQR would be 9. Again, box and whisker, the minimum and maximum are just dots. If it's just box plot, then they're lines. I'll show that in the examples up ahead. All right, make a box plot of this data, including the IQR. So again, we're finding measure of variance, we're finding the IQR. IQR is generally better than range, or safer, just because if you have an outlier, it won't affect it. Step 1, since we have to find the IQR, we need to find the median first. So we got to put things in number order. Smallest number here is 17. And then there's another 17. And then 19, 20, 21, 23, 26, 28, 29. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Do I have 9 numbers? Yes, I do. Okay, so 9 numbers, there's going to be one median, right? 1, 2, 3, 4, 5. The fifth number is the median, which splits our data in the first half and the second half, with the median not counting in either half. In our first half, the median of the first half would be the average of 17 and 19. 17 plus 19 is, oh my god, why am I so bad at this? 36. So 36 divided by 2 is 18. And then 26 and 28, that's 27. So we draw a box plot like this. If there's no number line, you just draw a generic box plot. And then we put numbers down. The minimum number, the smallest number, is 17. The first quartile is here. That's going to be 18. The median is the line inside the box, 21. So this is not drawn to scale, obviously, or else it'd be more spread out. But without a number line, we don't draw it to scale. Third or upper quartile is 27, and the maximum number is 29. And on top, I can put the IQR, the interquartile range. Again, this is the range of the third and first quartile, or how wide the box is. So this would be 27 minus 18, which is equal to 9. Again, if you want to label this is the minimum. This is the first or lower quartile. This number inside the box is the median. Here we have the third or upper quartile, and then we have the maximum, the largest number. All right, moving on to the next one. Here we do have a number line, so we have to actually plan a little bit better and draw it according to scale. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have an even set of numbers. We have 12 numbers. Put things in number order. All 30s and 40s. Okay, so let's start with 33, 35. I'm going to cross these out. 35, and then, oh, another 35. Phew, good thing I crossed them out. Then 32 37s. Then 38. And then any more 30s? No. Okay, 40s. 42, 45, two 46s. 45, two 46s. Oh shoot, there was a 40. Oh man. Okay, let me squeeze in a 40 here. And then a 49. Okay. This is 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 12 numbers, that's even, so there's two middle numbers. Darn it. So 12, that'd be 6 and 7. So 1, 2, 3, 4, 5, 6. Ah, you guys are going to say the meme, brain rot. So the two middle numbers are the 6th number and the 7th number here. So we need to find their average, right? So very important here. The median is neither of these numbers, right? The median is the average of these two numbers. So the median is actually right here between them, right? The average of 38 and 40 would be 39. This means I do count 38 in my first half because it is not the median. I used it to calculate the median, but it is not the median. I do count 40 in my second half because it is not the median. Okay, so there are 6 numbers in the first half and 6 numbers in the second half. So out of these 6 numbers, the median would be the average of 35 and 37, the third and fourth number. So that's going to be 36. And out of these 6 numbers, the average or the median, the middle two would be the average of 45 and 46. So that's going to be 45.5. Okay, so we know our first quartile, our median, and our third quartile. We also know our minimum and our maximum. So now we can plot the box plot. Our minimum is 33, so 30, 31, 32, 33. So I'm going to draw a line there. First quartile is at 36, so I'm going to draw a line there. Second quartile, or the median, is at 39, so I'm going to draw a line there. 45.5 is our third or upper quartile, so it's right there. And our maximum is at 49. Again, I'm connecting my first and my third quartile to make a box. And then notice how the box plot isn't symmetrical, and that's perfectly fine. We'll go over what that means in the next lesson. But for now, I'm going to just label this to be safe. 33, 36, 39, 45.5, and 49. And lastly, do not forget the IQR, right? The IQR is the difference between the first and third quartile. So in this case, 45.5 minus 36.0. Again, is the difference between the upper and the lower quartile, or the third and the first quartile. Subtract, I get 5, 9, just so, yeah. 9.5 is IQR. Pretty small variance, so the numbers are pretty close together. Moving on. All right, this time you're given the data as a dot plot. And we want to make a box plot of this data. I'm going to translate this data into numbers. There's 41, there's two 42s, 144, 3 45s, 2 47s. Oh my god, it's going to take a long time. 1, 2, 3 48s. I'll probably skip through this to see. 2 49s, 3 4 50s, 2 3 4. Oh my god, why did I choose this problem? 2 51s, Spare me 52, 53, 54, and 50. Oh, yes, it all fit. Okay, let's count. 1, 2, 3, 6, 8, 11, 13, 17, 19, 20, 21, 22 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. Yeah, okay. Everything's good. We have 22 numbers, that's even, so that means I need the 11th and 12th number as my middle numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my God. That means the middle number is 48.5, or the median. Our data is split 11 numbers in the front, 11 numbers in the back. Out of these 11 numbers, 11 is odd, thankfully, so the sixth number is the middle number. 1, 2, 3, 4, 5, 6. And then you're right, there's five numbers in front, five numbers behind it. Yep. So then five number 1, 2, 3, 4, 5 numbers in the front. That means this is the median of the second half, and then another five numbers behind it. Okay. We don't have a number line, so we can just make a box plot, generic box plot that's not drawn to scale, with our minimum and our maximum. Minimum is at 42. First quartile is at 45. Median is 48.5. Third quartile is at 50, and the maximum is at 56. But then don't forget this part, IQR, the interquartile range being 50 minus 45. So interquartile range is 5. I think that's all I have. Yep. All right. Good luck on the practice. Whoops, wrong button.